What if I told you that astronomers detected an impossible internal structure inside 3I/Atlas? We're not talking about normal density variations that comets present, but geometries that completely defy our planetary formation laws. Organized layers, symmetrical cavities, and thermal patterns suggesting something nature shouldn't create alone. If you want to stay informed about the mysteries of the universe, watch until the end because what this video has to reveal may change your perception of the cosmos. When 3I/Atlas was detected in July 2025, it initially seemed to be just the third confirmed interstellar visitor after Oumuamua and Borisov. Its hyperbolic orbit confirmed extrasolar origin, coming from some distant stellar system after millions of years wandering through interstellar vacuum. The first days of observation were scientific routine, orbital calculations, size estimates, preliminary spectral analyses. But as data accumulated, strange patterns began emerging that didn't correspond to any previously catalogued comet. The astronomical community realized we weren't observing just another casual visitor from deep space. What immediately distinguished 3I/Atlas was its anomalous chemical composition and incomprehensible optical behavior. While Oumuamua intrigued with its elongated shape and unexplained acceleration, and Borisov behaved relatively normally despite interstellar origin, 3I/Atlas simultaneously exhibited multiple anomalies defying coherent explanation. Inverted CO2-H2O ratio, extreme negative polarization, absence of fragmentation despite violent activity, and now, the most disturbing discovery of all. Its orbital characteristics suggested trajectory almost optimized for planetary flybys, improbable alignment with ecliptic plane, and timing that seemed calculated. Each new observation added layers of mystery instead of providing expected answers. Comparison with previous visitors revealed worrying pattern of increasing complexity. Oumuamua forced us to question our assumptions about interstellar object shapes and non-gravitational acceleration sources. Borisov confirmed some visitors behave like conventional comets, temporarily relieving anxieties about systemic anomalies. But 3I/Atlas seemed to synthesize all the strangeness of predecessors while adding its own, creating profiles so anomalous it was forcing fundamental reevaluation of how we categorize astronomical objects. The question was no longer whether interstellar visitors can be unusual, but whether some could completely transcend our established categories of natural. And then came the images that would transform curiosity into scientific urgency. High-resolution images captured after perihelion revealed something no astronomer expected to see in supposedly natural object. Thermal variation analysis using JWST infrared data showed heat distribution patterns not corresponding to solid cometary nucleus or even chaotically fragmented body. The surface exhibited distinct and stable thermal zones, as if different regions had dramatically different insulating properties, impossible in homogeneous rock or ice. More disturbing high-resolution spectroscopy revealed signatures of materials that shouldn't coexist in same structure. Complex organic compounds alongside refractory metals, volatile ices adjacent to materials requiring high temperatures to form. It was like observing iceberg containing pockets of lava, a fundamental physical contradiction. The geometry inferred from these multispectral observations defied established models of how celestial bodies form through gravitational accretion. When dust and gas collapse to form asteroids or cometary nuclei, result is always relatively homogeneous structure where similar materials naturally cluster. The process is chaotic and random, never producing symmetries or large-scale organizations. But 3I/Atlas showed evidence of distinct concentric layers, possibly internal cavities, and mass distribution suggesting organization impossible to result from random particle collision over millions of years. It was as if the object had been assembled rather than formed, constructed rather than accreted. 3 independent teams processed data assuming error, but all reached same disturbing conclusion. The internal structure doesn't make physical sense. International teams of astrophysicists are now fundamentally revising cometary formation models we considered established for decades. Papers being prepared explicitly admit we have no satisfactory natural explanation for observed configuration. Some propose exotic processes never observed before. Perhaps collisions in interstellar vacuum conditions produce structures that solar system collisions cannot, or perhaps interstellar magnetism organizes materials in ways our local physics doesn't predict. But these explanations sound increasingly like desperate rationalizations to avoid conclusion nobody wants to verbalize publicly. The structure of 3I/Atlas seems designed, And admitting this in rigorous scientific context is crossing Rubicon separating conventional astronomy from completely unknown territory. And we haven't even reached the most unsettling part of discoveries. When astronomers talk about hidden structure, they refer to internal features that cannot be seen directly but are inferred through how object interacts with radiation. Thermal variations reveal differentiated insulation, anomalous rotations suggest irregular mass distribution, transmission spectra indicate layer-by-layer composition. 3I/Atlas shows all these signatures simultaneously, painting image of complex interior with multiple layers of distinct materials, possibly separated by voids or well-defined interfaces. Its structure we'd expect to find in artificial satellite with separated functional modules, not in piece of rock and ice ejected from distant stellar system. The complexity suggests formation or modification process transcending normal chaotic accretion. Most conservative interpretations propose fragmented nucleus where ancient collision shattered interior but maintained cohesive exterior, creating rubble pile type object with fragmentary internal structure. But this doesn't explain apparent symmetry or observed thermal stability. Magnetic cavities, regions where intense magnetic fields separated materials during formation, are proposed as exotic but still natural alternative. Some speculate about exotic materials like metallic hydrogen ices or organic compounds in pressure states we don't fully understand, which could have unusual insulating properties. Each of these hypotheses requires extremely specific and improbable conditions, and none comfortably explains all simultaneously observed anomalies. It's like having 5 different puzzles and trying to force pieces to form coherent image. These hypotheses challenge known laws of astrophysics because they require processes we've never observed operating at necessary scale or in appropriate conditions. Formation of organized cavities demands pressure and temperature gradients that don't exist in cold molecular clouds where comets are born. Magnetic separation of materials requires fields much more intense than any known interstellar region could produce. Exotic materials in unusual states would need to survive billions of years of cosmic radiation exposure without degrading to more stable forms. Each proposed natural explanation violates at least one established principle or requires coincidences so improbable that combined probability becomes essentially zero. The scientific community is being forced to choose between accepting impossible convergence of natural anomalies or considering alternative traditionally belonging to science fiction. And some of the most respected names in astrophysics are beginning to verbalize the unthinkable. Avi Loeb, who had already proposed artificial origin for Oumuamua, is now asserting with greater confidence that 3I/Atlas exhibits characteristics consistent with deliberate construction or at least technological modification. His analysis focuses on statistical improbability of all anomalies appearing together by chance, arguing that Occam's razor, favoring simplest explanation, is beginning to point toward artifact hypothesis instead of impossible convergence of rare natural processes. Other researchers, more cautious in language but equally intrigued by data, suggest that even if not built by intelligence, it may be a result of physical processes so exotic they effectively represent new physics not yet discovered. Both interpretations are revolutionary and disturbing in their own ways. Defense of purely natural anomaly comes mainly from astronomers correctly arguing that absence of explanation doesn't prove artificial origin, only limits of current knowledge. They point out that science history is filled with phenomena that seemed impossible until understanding underlying physics. Pulsars initially called LGM for little green men, because regular signals seemed artificial, but proved to be neutron stars. Fast radio bursts were mystery for years before identifying magnetars as probable source. The argument is that 3I/Atlas may be equally impossible only because we haven't found natural explanation yet, not because one doesn't exist. This position is scientifically conservative and methodologically sound, but faces growing challenge as each new observation adds anomalies instead of resolving them. The community is divided not just about interpretation, but about how to even discuss possibility of artificial origin without destroying credibility. Scientists suggesting technosignatures risk being marginalized as speculative, damaging careers and losing access to funding and telescope time. But those refusing to consider non-natural hypothesis, even facing disturbing evidence, risk scientific negligence, ignoring extraordinary possibility for comfort of established paradigms. Fascination and skepticism coexist tensely in conferences and papers, with debates frequently more about sociology of science than data itself. Some argue we need completely new framework to evaluate anomalous interstellar objects, scale of artificiality probability based on objective criteria. But while this methodology is developed, 3I/Atlas continues defying comfortable categorization. If 3I/Atlas internal structure is confirmed as genuinely anomalous even after exhaustive analyses, it will force complete re-evaluation of how interstellar objects form, evolve and survive journey of millions of years through vacuum between stars. Current models assume only massive and cohesive rocky or icy objects can resist cosmic radiation erosion, collisions with interstellar dust at extreme velocities, and brutal thermal variations. Complex and organized structures should be destroyed or randomized by these processes over geological eras. If 3I/Atlas maintains complex internal architecture despite presumable age of billions of years, it implies either journey was much shorter than we assume, or materials are much more resilient than any known natural substance, or structure was actively maintained against natural entropic degradation. Implications for exotic matter search are profound because several natural hypotheses to explain structure require materials in states we've never observed in laboratory or terrestrial nature. Stable metallic hydrogen at low pressures, organic compounds in molecular configurations impossible to synthesize chemically, or even dark matter interacting in ways leaving indirectly detectable signatures. If any of these exotic substances is confirmed in 3I/Atlas, it would open entire fields of unexplored materials physics and chemistry. Alternatively, if structure is artificial, the materials question becomes even more fascinating. What advanced civilization could build something capable of traversing interstellar distances maintaining structural integrity for millions of years? It would be demonstration of materials engineering decades or centuries beyond our current capability. For intelligent life search, 3I/Atlas potentially represents paradigm shift from searching for distant radio signals to recognizing physical artifacts in our own cosmic backyard. If interstellar visitors can be probes or technological relics, then SETI needs to expand methodology to include detailed characterization of all anomalous objects crossing solar system, not just passive listening of electromagnetic frequencies. The importance of continuous observations before 3I/Atlas disappears back to interstellar space cannot be overstated because this may be a unique opportunity in our lifetimes to study object with these characteristics closely. Once it crosses heliopause and enters deep interstellar medium, it will be beyond reach of our best telescopes forever. We're literally watching historical window close in real time, and each day of lost observations is irreversibly wasted scientific opportunity. Ground observatories coordinated international continuous tracking campaign to maximize temporal and spectral coverage of 3I/Atlas before it becomes too faint for detailed studies. Very Large Telescope, Keck, Subaru and multiple European facilities dedicated priority time for high-resolution spectroscopy that can reveal layer-by-layer composition if rotational variations expose different internal regions. JWST is scheduled for deep infrared observations that will map three-dimensional thermal distribution with unprecedented precision. Radio telescopes will attempt radar detection that would reveal surface properties and possibly subsurface structures through echo return time analysis. Each instrument contributes a unique piece to puzzle that no isolated technique can completely solve. Scientists expect to confirm in coming weeks whether thermal and structural patterns persist as object rotates and its solar illumination geometry changes. If anomalies are observational artifacts or viewing angle effects, they should vary or disappear under different observation conditions. If they're genuine object features, they'll remain detectable regardless of perspective. Analyses of possible perihelion fragmentation that could have altered internal structure will be definitive when higher resolution images are processed. Comparisons with sophisticated computational models of cometary formation and evolution will determine whether any combination of known natural processes can produce observed architecture. But there are already private bets among astronomers about whether natural explanation will be found, or if we'll have to admit we don't know what we're observing. If this structure is real and remains unexplainable by conventional physics, we'll be facing new frontier of astronomy where interstellar visitors aren't just curiosities but potentially messengers of unknown physical processes or even distant intelligences. The line between traditional astronomy and speculative astrobiology is blurring because 3I/Atlas forces questions transcending established disciplinary categories. Regardless of final conclusions, this object has already transformed how we think about interstellar space from sterile void punctuated by random rocks to region potentially filled with complex and enigmatic objects defying our fundamental assumptions. The mystery won't end when 3I/Atlas disappears from sight. It will only evolve to next phase where we debate what it taught us about limits of our knowledge and possibilities we haven't seriously considered. The universe is showing us there's more between the stars than our scientific philosophy dreamed. Tentar Novamente.